You come around a corner, and the moon is sitting on the rooftops. And it's huge, too big for the street, low and orange, and close enough that it looks like it's coming down. So you take a photo because you have to. The photo is a white dot above a car park. The camera didn't get it wrong. That white dot is the size the moon actually was. It's the size it is every night, overhead, when nobody looks twice. Your phone measured it. You saw something else. Most people will tell you that's the air near the horizon, bending the light like a lens. It isn't. Nothing out there changed size. Whatever made that moon enormous happened entirely inside your head, and after 2,000 years of people trying to explain how, nobody can. Start with the part that's settled. Photograph it low, photograph it high. Same camera, same zoom. The two discs come out the same. No measurement anyone has ever taken shows that disc swelling on the way down to the horizon. The air does do one real thing to a low moon. It bends the light and it squashes the disc slightly. It makes it a little flatter. It doesn't make it bigger. The one visible effect the atmosphere has runs in the wrong direction. And then there's this. When the moon is directly overhead, you're standing on the side of the planet facing it. The whole 4,000 miles between you and the center of the Earth is working in your favor. So you are closer to an overhead moon than you are to one sitting on your horizon. About 4,000 miles closer. So the moon you see over the rooftops is genuinely smaller. About 1.5% smaller. You cannot see 1.5%. Nobody can. That's not the point. The point is that everything physical in this situation is pushing gently in the opposite direction and losing badly to something happening entirely inside your head. Like and subscribe if you want more of this. Things in the sky that refuse to behave, and things your own eyes get wrong every day without ever mentioning it. Because it isn't even the moon doing this. Watch a sunset. The sun does exactly the same thing. Enormous on the horizon, ordinary once it's up. Constellations do it too. A star pattern near the horizon looks stretched and huge, and then it climbs, and it shrinks back to normal. Nothing about this is lunar. The moon is just the brightest thing that happens to be down there. There's a video on this channel about why you only ever see one face of it. Short version, it does spin. Exactly once per orbit, which is the only reason the face never changes. And if you want to know what a genuinely bigger moon looks like, the moon's orbit isn't a circle, so sometimes it's closer to us than others. At its closest, it's about 14% wider than at its farthest. That's the entire real range available. 14%, and people write articles about it. Whatever's happening on the horizon is doing considerably better than that, with nothing. You can take this apart yourself, tonight. Start with the size it actually is. The moon is about half a degree across. Half a degree on the horizon, half a degree overhead, half a degree wherever it is in the sky. On the night it looks impossible, hold up your thumb at arm's length. Your thumb covers it. Then, take the sky away from it. Roll a sheet of paper into a tube and look at the low moon through it. Or curl your hand and look through the hole in your fist. Take away the rooftops, the trees, the horizon, all the sky around it. Just the moon, in a small circle of nothing. It shrinks. It's suddenly the same unremarkable disk it is at midnight. Or, and this is a real recommendation, go outside, bend over, and look at it upside down, between your own legs. It shrinks then, too. Nobody entirely agrees why that one works. So what is going on? The answer you'll find almost everywhere goes like this, and it's a good answer. You don't see the sky as a dome. You see it as a flattened bowl, a ceiling, pressed down. The horizon feels enormously far away, and the point directly above your head feels much closer. That's why the sky looks like a lid and not a sphere. Now, your visual system corrects for distance constantly, and you never notice it doing it. Someone walks away from you down the street and shrinks to a fraction of their size on your eye, and they do not appear to shrink. You just see a person further away, still the right size. So, two moons, the same size on your eye. One of them is filed as being very far off, out past the horizon. The other is filed as being much nearer, just overhead. And the far one has to be enormous, or it could never look that big from all the way out there. And that's what you get, an enormous moon. You've seen this trick in 2 dimensions. 2 identical bars laid across railway tracks running away into the distance. The far one looks longer, every time. Knowing it doesn't help. And there's evidence. Block the landscape out and the effect weakens. Show people an artificial sky with the terrain removed and the big moon deflates. The ground you can see seems to be doing real work. That idea is about 1,000 years old, and it's still the one in the textbooks. There's just a problem with it. For that story to work, your visual system has to have registered the horizon moon as the far one. That's the whole engine. Far away, same size on the eye, therefore enormous. So ask people. Ask someone standing in front of that ridiculous orange moon whether it looks far away or close. They say close. Overwhelmingly, people say the horizon moon looks nearer, bigger and closer at the same time, which is precisely what the explanation needs them not to say. It has a name. It's called the size-distance paradox, and it has been sitting in the middle of the standard explanation for decades, being argued about by people who are otherwise perfectly happy with each other. There's a defense, and it's not a bad one. The distance your visual system quietly uses isn't the distance you can report. You get the size first, and then the feeling of closeness comes from the size, backwards. Some people who study this find that convincing. Plenty don't. And the terrain isn't the whole story either, because you can get the illusion in complete darkness. No horizon, no rooftops, no landscape to be far away. It happens anyway. Which brings us to the part of this I actually like. Aristotle noticed it and said it was vapor in the air. Ptolemy said the air worked like water, magnifying it the way a coin looks bigger at the bottom of a bowl. 1,000 years ago, a scholar in Cairo said, "No, it's the shape of the sky. We read it as flat, and that's what does it. Closer than either of the others, and we are still arguing about it." Every one of them was certain. Every one of them was explaining the exact thing you saw over the rooftops last week. And after 2,000 years, the only part everybody agrees on is the negative. It isn't the air. Nothing out there changed size. That isn't the same as nobody having any idea. There are good accounts and a great deal of careful work behind them. It's that none of them has won. So the impossible moon over the rooftops is 1/2 degree across, and your thumb covers it. And what you're really watching on a clear night over a car park is your own visual system making a guess about how big the world is, out loud, in front of you. And nobody has been able to tell you how it does it.